Hello, this is Terri again with part 3 of my current understanding of our universe. And first aspect of that, part 2 was about point 5 and 6. So I'm not sure if I mentioned that. So so the first thing is that we have an atmosphere. I'm going to remove polrs. This is my polrs. And if you're looking above our dome, at some point, if you were able to look above through our dome, you will see some effects of our atmosphere. The atmosphere is invisible, but the grill is my presentation or depiction of the atmosphere. Okay, and we'll remove this. So the grill will also represent star trails in this presentation also. But we have an atmosphere, and everything we view is through our atmosphere. So there has to be some constant refraction, and I believe that's why I'm gonna go underneath first before I go on, so that we'll get a view from the plane. Okay, so we have a view from the plane, and we have an atmosphere. So everything we see, all our cosmos and the dome, the celestial tapestry, is all through an atmosphere. And the atmosphere may change, but still we will likely have some refraction constantly. And so that means to me that we have no distinct place or location of our lights, because there is some kind of refraction. And I think that's why we have a personal experience, because the lights are projected. And I think that's why we have rainbows, and the experience we have with rainbows are personal, and crepuscular rays. I think all that is because the lights are projected in through a medium, an atmosphere, and the lights are refracted. So the next aspect is the opposite rotations of our star trails. And this is my understanding of that. So I'm going to remove polrs again. And I think this is a universal effect. When you're looking at along the line of rotation for anything, and you have two opposite views, two opposite directions, the opposite directions are going to present with opposite rotations. So I'm going to turn my plate. That's the point of the microwave plate in the wheel, so I can turn it. And I'm turning it so that we can see a counterclockwise rotation from this viewpoint. And clockwise would be the hand of a clock going this way. So looking from this viewpoint, actually I should do clockwise, actually, because so this is kind of the viewpoint from the folks who are 0 to 45 degrees plus to 90 degrees. They're kind of looking down, so they see a clockwise rotation. So that would be more accurate. Okay. Because of the effect of the dome height and the dome breadth is so extreme that the further out you go, those who pass the 45 degree mark of the plane latitude, it's like an effect of looking down the dome, and they see the stars and the star constellations from that viewpoint. So the effect is as if they're looking down. So and they get a clockwise rotation. So I'm going to continue to turn it clockwise. Then I'm going to move the camera down here and looking up. And so now it's presenting counterclockwise. The way those of us who are 0 degrees to 45 degrees latitude are looking up the dome, and we see a counterclockwise rotation. As you can see, I'm still twirling the same way, same direction. See, clockwise. and counterclockwise. And I think that's what's happening, because we know for sure there's not a North Pole per se, and there's not a South Pole for sure. But that effect is partially of why we have different star trails, constellation stars, and opposite rotations. The other effect that we have is a vantage point with the dome. So I'm gonna show. This is one of my models of the dome, and so when we're moving away from Polaris, if we're under Polaris directly at Arctic center, ground zero, and we're moving away. So that's what it looks like. You can see that Polaris is finding its horizon. It's moving down. Okay, so now if we have a much larger foil, you would only see sky and foil. Okay, and you would see a different portion of the sky as Polaris seems to be moving lower. So Polaris moves seemingly according to the distance traveled on the plane latitude. So if you travel 10 degrees from the Arctic center, then Polaris is going to seem to move down 10 degrees. You travel 20 degrees, Polaris is going to seem to move down 20 degrees. And you don't see the lower portion of the dome, but you would see more foil, like you would of mycelium. You see more of another part of mycelium with my other example of the sky. And that's what would happen with, that's what happens. That's the effect of moving away from the Arctic center. And the dome kind of is finding its horizon. And so at the same time, as it's rotating, and it's kind of also rolling, the sky's kind of rolling, and you're getting different portions of the sky. And at some point, at the 45-degree mark plus, the moon is going to look like it's upside down, because that's the effect of moving away from Polaris. The effect is kind of a rolling sky. Okay. And it's hard to show because that's too heavy, and you really need the breadth to show the effect, that you only see portions of the dome, half, and so people are going to see different portions of the sky at different latitudes. So when you're past the 45+ degree mark at those latitudes, you're going to have a totally different sky view and a totally different effect with the moon and your star trails. So let me show you star trails again. So let's say that's a star trail, and I'm going to twirl it from this way. So from looking down, you get the clockwise rotation of the star trails. Like you would from 45-degree plus to the 80-degree latitude, you get a clockwise rotation. And if you're inside the 0-degree latitude to 45-degree latitude, you're going to get the